Stand outside right now, close your eyes, and let the sun hit your face. Feel that warmth for a second. It started its life 8 minutes and 20 seconds ago, deep inside a star 93 million miles away, and it has been traveling in a straight line ever since, through empty space, waiting for a face to land on. Open your eyes and look at it. You are not looking at the sun. You are looking at a photograph of it, 8 minutes and 20 seconds late. So here's the question. If the sun blinked out of existence this instant, gone completely, how long before you noticed? Longer than you'd think. Light is an instant. It crosses space at a fixed speed, about 186,000 miles a second, and the sun is far enough away that its light takes 8 minutes and 20 seconds to reach you. For that entire window, the sky would look exactly as it does right now. Nothing missing, nothing dimmer. You'd be staring at a star that, as far as the universe is concerned, had already stopped existing minutes earlier. Here's the part almost nobody expects. It isn't only light that's delayed. Gravity is too. Under Einstein's general relativity, the news that a mass has vanished doesn't reach the rest of the universe instantly. It travels outward at the same speed as light, as a ripple in space-time. So for that same 8 minutes and 20 seconds, Earth would keep calmly circling a star that in truth was no longer there to hold it. Then the 8 minutes end. All at once, everywhere, the sky goes black, and the planet stops curving. This is the part that surprises people the most. You might picture Earth just freezing in its orbit, drifting to a stop. It wouldn't. The only reason any orbit curves is that something is constantly pulling it off a straight line. And Newton's first law says that once that pull disappears, motion doesn't stop. It goes dead straight. Earth is moving at roughly 67,000 miles an hour right now. And with nothing left to bend that path into a circle, the planet would simply fly off tangent to its old orbit, in a straight line forever, carrying every ocean, mountain, and city with it into the dark. This isn't purely a thought experiment confined to Earth, either. Astronomers already track real free-floating planets like this, worlds with no host star at all, spotted by watching them briefly bend and brighten the light of a background star as they drift past, a technique called gravitational microlensing. A more recent demographic survey by that same research group estimated that rogue planets like this may outnumber star-bound ones by roughly 6 to 1 across the galaxy. Earth, cut loose from the sun, would simply join a population that already exists. The cold arrives almost as fast as the darkness. According to estimates from planetary scientist Michael Summers, Earth's surface would begin cooling by roughly 20 degrees Celsius, about 36 degrees Fahrenheit, every 24 hours. Within 2 to 3 days, nearly the entire planet would already be below freezing. It wouldn't hit everywhere at the same rate. Small, shallow water, a garden pond, a puddle could freeze solid within days. Lakes with more water to cool would hold out for weeks. The ocean, holding by far the most heat, would resist the longest of all, which becomes very important later. Underneath the cold, a second collapse starts immediately: photosynthesis. It depends entirely on sunlight, so the instant the light is gone, it stops completely everywhere all at once. Most small plants begin dying within days to weeks. Large trees can hold on for years, sometimes decades, living off sugar they'd already stored, but the base of the food chain is already gone. Everything above that base follows in order. Herbivores starve once the plants are gone. The predators that eat them get a brief reprieve, scavenging the dead, but that supply runs out in days, not months. Layer by layer from the ground up, the food chain empties out. Here's where most people guess wrong about what actually kills you. You'd assume the air runs out, that without plants replacing it, oxygen becomes the emergency. It doesn't. Even with photosynthesis completely stopped, the oxygen already sitting in Earth's atmosphere would keep the air breathable for over 1,000 years, and some estimates put full depletion millions of years away. Cold and starvation would end nearly all surface life long before suffocation ever became a threat. The one thing you don't have to worry about is the one thing everyone assumes you should. Zoom out to a year, and the planet is unrecognizable. Average surface temperatures would fall to around minus 73 degrees Celsius, minus 100 Fahrenheit, colder than anywhere ever recorded on Earth, roughly what a mild day on Mars feels like. It's worth being honest here. Not every model agrees on exactly how fast this happens. Some estimates, focused only on the thin surface layer of the biosphere, get to freezing in as little as 38 days. Others, which properly account for how much heat the oceans alone can hold, stretch that same milestone out to around 400 days. The gap between them is close to tenfold, a reminder that how fast depends heavily on what exactly you're choosing to measure. What almost every model agrees on is this: the ocean is the planet's insurance policy. Its surface would freeze within months, but that ice layer, once it forms, acts as insulation, slowing heat loss to the water still underneath. The deep ocean could stay liquid for thousands of years, in some estimates far longer, sheltered under its own frozen lid. Around a decade in, the sky itself starts falling. Carbon dioxide is the first gas cold enough to freeze out of the air, drifting down as dry ice snow at around minus 78 degrees Celsius. Given more time, nitrogen follows. Eventually, even oxygen freezes and joins the snowfall, meaning the very air you're breathing right now would, centuries later, be lying on the ground as frost. What's left is a planet with a permanently dark, permanently snowing sky, wrapped in a shell of its own frozen atmosphere and ocean, no longer orbiting anything, drifting through interstellar space in the straight line it took at the very start of all this. But under all of that ice, something would still be alive down there, and it wouldn't even be new to Earth. Around volcanic hydrothermal vents on the ocean floor, whole ecosystems of tube worms, shrimp, and microbes already live without ever seeing sunlight, building their energy from chemical reactions in the vent water instead. They wouldn't notice the sun was gone. Earth's core keeps generating that same kind of heat on its own, from the slow radioactive decay of elements in the mantle, completely independent of the sun. Physicist David Stevenson at Caltech has estimated that the surface would eventually settle near minus 240 degrees Celsius, minus 400 Fahrenheit, the point where that internal heat exactly balances what the frozen shell radiates away into space. That's uncomfortably close to how some of the icy moons out in our own solar system, Europa and Enceladus, already exist today. A frozen shell above, hiding a liquid ocean below, kept warm by nothing but the moon's own interior. If life can exist in oceans like that without ever seeing a sun, it's already out there, right now, a few 100 million miles from where you're sitting. None of this is going to happen. The sun has roughly 5 billion years of fuel left, and it isn't simply going to vanish. But here's the twist inside the twist. The sun losing you isn't the real long-term danger. It's the opposite. As the sun slowly brightens over the next billion years, it will eventually boil Earth's oceans away instead. Researchers Kazumi Ozaki and Christopher Reinhard calculated, in 2021, that this brightening will strip Earth's breathable oxygen down to roughly 1% of today's level in just over a billion years. Losing the sun and losing to the sun turn out to be two versions of the same ending. So the next time you feel sunlight on your skin, remember what you're actually feeling. Light that already left its source 8 minutes ago, gravity holding you in an orbit built on that same delay, and a star that, on any given day, you are only ever seeing 8 minutes into its past.